So we hatch a batch of eggs in the lab.
And where do you get the...
From the poultry breeders who supply them to the battery.
Oh, the intensive.
Or they're going to a farm, but either way...
So either way they're
Either way, by 12 weeks they'll be plucked and lying on their backs.
In a supermarket?
On your table.
So you're not taking the life.
Well, I am taking the life.
But even if you didn't, they'd still be...
They wouldn't live to be old chickens. No.
Okay, so you've got the chickens?
Yeah, about a day old, fluffy, yellow, like little Easter.
And you do some experiments on them?
Well, what we do is we get them to peck.
Because chicks do peck a lot.
They peck everything. So we get them to peck these beads that have either been dipped in water or some stuff that tastes bitter.
Not poison.
No, but they wipe their beaks off on the floor after, so they're fine. And of course, we're writing all this down, you know, which chicks, which beads, how many pecks, and then my colleague injects a tiny amount of very slightly radioactive liquid in each side of the chick's brain. No, but they don't show any.
It doesn't hurt.
No, they don't seem to.
Okay, so what's it for? It's going to show up something in their brains?
Well, because what we inject has sugar in it that gets used by the nerve cells. So the more sugar that is being used, the more brain activity. And then the radioactivity is used as a kind of tracer, like in a scanner. So we get to measure it.
And the idea is it's different in the different...
Well, we hope that it's different.
So depending on what the chicks learned about...
Yeah, so we give them the beads again, and they have learned, because the ones who had the beads dipped in water, they come back and peck it. And the ones with the bitter beads have learned not to peck it.
That's terrific.
That's not what we're finding out. What we're finding out is...
It changes in the brain.
Changes in the brain that correspond to the memory.
So, to do that, you have to...
Well, yeah, I take a chick in my left hand, and I quickly cut off its head with a big pair of scissors. And then I put it in a tray of ice, and my colleague cuts it into thin slabs with a razor blade and dissects out a sample that he puts in a test tube that's immediately frozen. And then I, take out the brain of the next chick.
Yeah.
And that's what I do.
And then you analyze.
Yes, and there is substantial increase.
So you can measure...
Yeah, it's not just the increase, but also exactly where you can slice.
Slice the brain?
Slice the thin brain. Slice the frozen brain into thin slabs that you can put on a slide, and you get pictures.
So you can see...
You can see the difference in the darkness, and also you can use false color, which of course makes it...
Prettier?
Prettier, yes, but also easier to read, though the information is the same.
Which is...
Oh, that the learning takes place on the left side of the brain.
And you can see.
And then there's another version where you soak the sample in silver salts, and you can see the new spines on the dendrites.
It's the little tiny...
Because of that degree of magnification, the sample is 250 meters wide.
And you can see the memory.
You can see the actual changes.
See what the chicks learned about the bead.